Hello everyone, this is Shrawan Sir, making maths simple for you. Welcome to my YouTube channel Karna Maths Academy. Today in this video, we are going to prove section formula which is from the chapter of coordinates in space. Dear student, in the previous video, already we have proved the formula of distance between any 2 points in the space, the distance of any point from the origin. So dear student, if you have not watched the previous video, please watch it so that it will be easy to understand the proof of section formula. Here we go. Dear student, according to the section formula, the coordinates of any point. In the section formula, we find the coordinates of any point we suppose as px, y, z. We find the coordinates of a point which divides the line joining any two given points in a given ratio. So let's make a diagram. Dear student, in the section formula, we have to find the coordinates of the point. Let's suppose the coordinates of the point P is x, y, z, which divides the line joining any two given points A and B in the ratio of m₁:m₂. The coordinates of the point A and B, the two endpoints of a line segment, will be already given. So dear student, we suppose that x2, y1, z1 and x2, y2, z2 are the 2 points, are the given 2 points, which is divided by the point P in the ratio of m₁:m₂. So dear student, now according to the section formula, x will be equal to m1 times x2 plus m2 times x1 divided by m1 plus m2. Y will be equal to m1y2 plus m2y1 divided by m1 plus m2. And z will be equal to m1z2 plus m2z1 divided by m1 plus m2. So this is the sectional formula for internal division. In the case of external division, we take negative sign, plus sign we replace by minus. That means x will be m1x2 minus m2x1 divided by m1 minus m2. Y will be m1y2 minus m2y1 divided by m1 minus m2. And z will be m1z2 minus m2z1 divided by m1 minus m2. So dear student, in case of internal division, we take positive sign, and in case of external division, we take negative sign. So dear student, now to prove this formula, let us draw the diagram which we need to get the proof of the section formula. So dear student, at first we take 3 mutually perpendicular lines. We take 3 mutually perpendicular lines, OX, OY and OZ, because we have to find the coordinates of the point P, x, y, z, which is in this space, and the point P divides the join of any two given points in this space in the ratio of m₁:m₂. So we have to take, at first we have to, now we take 2 points, 2 given points A and B, which are in this space. And dear student, we have to find out the coordinates of the point P, which divides the join of AB in the ratio of m₁:m₂. P divides AB in the ratio of m₁:m₂. Dear student, now from the point P, we draw a line perpendicular to xy plane, and again we draw another perpendicular line from the point B on the xy plane. We join both the points. From the point P also we draw perpendicular on the xy plane. From the point P we draw perpendicular line. Let's say AQ, AP, PQ and BR are the perpendicular lines from the point APB on the xy plane. We draw PC perpendicular to BR and we produce PC At first we draw PC perpendicular to BR, then we produce PC to meet AP produced at D. So dear student, this is the figure we need to prove the sectional formula. So dear student, now the two triangles BPC and APD, they are similar triangles because vertical opposite angles are equal and angle A and angle B are equal because the lines AP and BR, they are parallel because both they are perpendicular on the xy plane. So the line AP and BR, they are parallel, so angle A and angle B will be equal because they are corresponding angles. So these two triangles are similar. So let us take the ratio of, in the similar triangle BPC and APD, in the similar triangles BPC and APD, let's take the ratio of AP and BP. And let's take the ratio of AP and BP because AP and BP already we know m₁, m₂, because P divides AB in the ratio of m₁:m₂. And let's take the ratio of AD and BC. Dear students, let us substitute the value of AP and BP. AP is m₁ and BP is m₂. And let us find the measure of AD and BC. AD and BC. At first, let us find the measure of BC. Dear student, the measure of BR is Z2 and the measure of CR is equal to PQ. And the measure of PQ is Z. So Z2 minus Z will be the measure of BC. Let's find the measure of AD. Dear student, PD, or we can say DP and PQ are equal because a rectangle is formed in this space, and we know that opposite sides of rectangle are equal. So AD and PC are equal. So the measure of AD and PQ will be equal. Both will be equal to Z. And we know that AP is Z1. So from Z, if we subtract Z1, then the measure of AD will be Z minus Z1. So the measure of AD will be Z minus Z1. Let's do now crisscross. m₁z₂ minus m₁z equals to m₂z minus m₂z1. Dear students, we have to find the value of z, x, y and z. So from this we can get the value of z, the z coordinate. So let's write down the coordinates having z on the same side. So dear student, m₁z moving to the right hand side, minus will change into plus. m₂z keeping as it is, m₁z2 keeping as it is, and minus m₂z1 moving to the left hand side. So dear student, now if we take z common from the right hand side, keeping m₁z2 plus m₂z1, keeping the terms of left hand side as it is, and taking z common from right hand side. So dear student, now we get the value of z. The value of z will be equal to m₁z2 plus m₂z1 divided by m1 plus m2. So dear student, this is the z coordinate of the point P, which divides the join of AB in the ratio of m1:m2. So value of z is m₁z2 plus m₂z1 divided by m1 plus m2. So dear student, by following the same process, we can get the x and y coordinate of the point P. So dear student, x coordinate will be m₁x₂ plus m₂x₁ divided by m1 plus m2, and y will be equal to m₁y₂ plus m₂y₁ divided by m1 plus m2. So dear student, to get the z coordinate from the given 2 points A and B, we have drawn perpendicular on the xy plane. Similarly, to get the coordinates of x, we have to draw perpendicular on the yz plane, and to get y coordinate, we have to draw perpendiculars on the xz plane. So dear students, by following the same process, we can get the x and y coordinate of the point P. So dear student, I hope that you have understood how to prove the sectional formula for internal division. So thanks for watching this video. Next time we'll meet with a new content. Till then, bye, have a nice day. Thank you.